started. And we are starting in Chapter 5, and why I start in Chapter 5. A lot of you are going to take tests this year, important tests. And the problem is, if we wait till the end of the year to get to this, you've already taken like your SATs and all that kind of stuff, PSATs and all of that stuff, and ACTs. So we want to get to it early so that you know it and you got it down before you take big tests. Also, chapters 1 through 4 is basically Algebra 2 review, which is sometimes nice to do at the end of the year when your brains are already fizzling out and you got more pressing stuff to do you're seeing stuff that you've already seen before. All of this stuff will be basically brand new. So it's nice to just hit you with the brand new stuff, get through that stuff, and then it's kind of on the back end, more of a review style kind of situation. So that's why we're going to start at Chapter 5 today. And Chapter 5 talks about, we're going to start with just angles. Just angles. We're going to primarily talk about degrees. We've heard of angles before. We've had squares where you have like the little square in the corner. That means it's 90 degrees. Same thing. We had 180 degrees was a straight line. We still have 180 degrees. 360 degrees is still a full circle. So that's what we're talking about. However, when we're talking about in pre-calculus, when we talk about angles, we kind of confine it to an XY plane with this circle around it. This is going to become our unit circle. And our unit circle, we're going to slowly build up to knowing all of these values. Very nice. You'll know this soon. It's not as bad as it looks. We just slowly build up, and before you know it, you're going to actually know the stuff. But this is the basics of it. So, measures of angles. We're going to start with degrees. We'll make it a little more complicated, and then tomorrow we'll talk about radians, which are kind of a different measure of it. But standard form of a rotational angle. In trig, the initial side is called the initial side of the angle lies on the positive x-axis. So this right here is the initial side of my angle. It's kind of like our starting off point. And the other one just rotates and stops at some point. It's like a spinner. So we start here, and we either go that way or we can go that way. But the initial side starts on that positive x-axis, and the terminal side rotates counterclockwise for positive and clockwise for negative angles. That's why if we look down here, this one said I rotated this way, it's a positive 120. This one went clockwise, so it's a negative 240 degrees. So we all start here, and then something happens with this spinner. Initial, terminal. That's my initial side. That's my terminal side. This arrow tells me which direction I'm going, whether it's positive or negative. Now, why this is 120 degrees? Well, we can eyeball it. We can eyeball it right now. We'll get more precise later. But the reason why we can eyeball it with the knowledge that we have right now, we're going to label some of these axes. So I'm going to start with just 0 degrees. 0 degrees is right there. If it doesn't move, it moves 0 degrees. Now, if this angle swings right here and goes straight up and down, that's a 90-degree angle. So that's 90 degrees. If it swings all the way back to the x-axis on the other side, now we're talking about 180 degrees. And then down here it'd be 270 degrees. So this angle went from here to here. It's somewhere between 90 and 180. So if we had to make an approximation, maybe it wouldn't be 120. If I said just approximate that, you might say 130, you might say 110, something like that. If I just said approximate it, anything around there is fine. Basically anything between 90 and 180, as long as you kind of recognize that. When we're going in the negative direction, we can label this just in the opposite direction. We'll still start at 0 degrees, but instead of going up here, we're going to come down here with negative 90 degrees. And then we'll go to negative 180 degrees, and then we'll go to negative 270 degrees. So this swings around and is somewhere between negative 180 and negative 270. Negative 240 seems like a pretty good shot at that. This is not something that would happen. I wouldn't ask you what degree this is without having arrows on it because you need to know if it's positive or negative. The reason why I have this on here is the fact that angles can spin around over and over and over again, and that actually adds to the total. So what I'm going to do is I'm going to draw this on this last one. I'm going to actually spin all the way around, and then I'm going to end there. So this angle actually spun all the way around and ended right here. How many degrees does it take to spin around in a circle? 360, right? Yeah. Okay, I thought you said 60. Like, oh. Yeah, 360 degrees. So this angle went all the way around 360 degrees, and then it went a little bit further. So this part's easy, 360 degrees. Now we just have that little bit. Really, that little bit's all we really care about, because however many revolutions, it's just 360. 720, 1080, and just keep adding 360. What I really care about is this little bit here. Well, we already said that little bit is 120 degrees. So this angle is just 360 degrees plus that little bit more. So this is just 360 degrees plus 120, which in my book would be 480 degrees. And it can keep spinning. I can keep adding 360 to it. As many times as I want to draw that spiral on there, I can. All right, questions on spinning that angle? Okay, makes sense? Negative, positive? All right, the terminal side of an angle will lie in one of four quadrants. One of four quadrants. We have 1, 2, 3, and 4. And remember, that goes 1, 2, 3, 4. So all this is asking me to do is this is my initial side. This is my initial side. I'm not too worried about the initial side because it's always there. Always. Always there. What I'm worried about is the terminal side. What happens when this side spins around 1,225.6 degrees? Where is it on here? Just got to plan to at least start. Yeah, Brody.
Well, you can go around 3 full times. Is that what you're asking?
Yeah, that's what I'm asking.
So yeah, you can go around 3 full times, and then you have to figure out how many degrees you have left over, where it would be.
That's exactly what you need to do. I don't care about the 360s. I want to subtract away 360s as many times as I can before I get that little bit left. Kind of like if I said 480 degrees. If you subtract 360 away from it, you know it has to go 120 degrees. So it's one full circle plus that little bit. I want to subtract away 360s to figure out how many turns there are and then get that little bit after. There are a ton of ways to do it. The way I'm going to do it is probably one of the most complex but most mathematically sound. I think the easiest way is just subtract 360 until you get to that angle you have left over. Right? If I just subtract 360, subtract 360, subtract 360, I'll have basically what angle I need left over. So if you get lost in what I'm doing right now, just remember at the end of the day, you can just subtract 360 until you get to the angle you want to. So Brody said we want to figure out, you figured out that there's 3 full rotations in there at least, right? So the mathematical way to do that is just to do 1225.6 and see how many times 360 goes into it. And we're looking to see how many times it goes evenly into it. But a good idea is always just to plug that bad boy in your calculator, doing 1225.6 divided by 360. So we might as well do it if you have a calculator. Did you already get it, Chris? It's 3.40, something around there, right?
Yeah,
It's more decimals. Yeah, dot. But what I really care about is this 3, because that means there's 3 full rotations and then something extra. So what I'm going to do with that 3 is I'm going to go 3 times 360. 3 times 360, and I'm going to subtract that away from 1225. So we're going to do 3 times 360, which is going to be 1080. So I'm just subtracting 360 over and over and over until I get to the last number. And then we're just going to do 1225.6, not equals, minus 1080. And what does that equal? For those falling around or ahead. Daniel?
Is it 145.6?
145.6. We all see it's maybe not the easiest way to show what we're doing, but do we get what's happening? Do we at least get what's happening? I don't expect you to do this on the test. I might do this on the test because I like the logic behind it. But sometimes it's just easier to subtract 360 until you're left off with 145.6. Because now it's 145.6. Now we can figure out where that terminal end is going to be. I'm actually going to extend this out just a little bit further. Because this is 0, this is 90, this is 180 degrees. Well, I don't have to go any further than that because 145 is somewhere between 90 and 180. So maybe we're here. And that means that this goes around, and it's kind of hard to draw. I'm not really worried about the drawing. But we'd go 1, 2 times, 3 times, and we'd end there. But does the question say, draw me a perfect picture of it? No, it just says what quadrant is it? What quadrant is it in?
Oh, I was just gonna ask.
Oh, go ahead.
If how do we know when to stop subtracting 360 from that?
When you get negative.
Oh.
Because once you go to negative, you went too far. I'm looking for something between 0 and 360 degrees. So as soon as you go negative, you went too far, add 360 back to it. All right. Did you have a question?
Oh, I was going to answer your question.
Oh, answer my question.
The second.
Second quadrant, yep. So Chris, we are either trying to add or subtract 360 until we're somewhere between 0 and 360. Because if we look here, I have negative 95. We can either graph negative 95, or we can add 360 to it to see what the positive version of it is. Either way will work. Maybe I want to do that. Nah, we'll just go negative. We'll just go negative with it. All right, negative 95. Let's remember, we can go in the negatives. So I have 0 degrees. I have negative 90 degrees. Really, that's as far as I need to go because we know it's just a little past 9 degrees, and it's going to be in quadrant 3. What's negative 9 plus 360? You can do it in the calculator. I don't care. I'm not offended. Fritz?
351.
What was that? 351?
So negative 9 plus 360.
No, it's negative 95 plus 360. I didn't say that. No, I'm just kidding. I don't know. Yeah.
265?
I don't know. Is it 265?
I think it is.
Yeah. All right, 265. Guess where 265 is? In the exact same place. So if you add 360 to it and you do between 0, you get to the exact same place. All right, negative 225. Someone tell me what quadrant that's in. Brody?
2.
Quadrant 2. I agree with you 100%, but let's actually do it just in case. 0%, negative 90 degrees percent, negative 180 degrees, and this is negative 270 degrees. 225 must be somewhere between here. And so we are in quadrant 2. If they're really big negatives, like say I asked you to find what quadrant negative 2,225 is, what I would do is I would add 360 to it until it's the smallest positive between 0 and 360. Because it is a lot easier to graph things in the positive direction than having to redraw stuff in the negative direction. All right, just human nature-wise, it's just easier to go to that positive 0 to 360 and picture stuff. All right, questions on either one of those? Or all? Yeah, we have 3 of them. Okay. You know that big unit circle that we made? We're going to start with the smallest thing, listing all of the degrees that are important to this class. There's only so many degrees that are really important in this class that we're going to go use over and over and over again. Well, I already showed you 4 of them. So we have 0 degrees, we have 90 degrees, we have 180, and we have 270. And a lot of people just come all around and go 360. All right, they're like, if I get all the way back here, 360. Bless you.
Thank you.
You're welcome. Now the middle ones. Now some people, this is how I usually label it if I want to go really, really quick, if we're doing some kind of timed thing. I know this is 45, but I'm going to forget about that for a second. What I want to focus on are these ones. All of those are increments of 30, and it's nice because you can check your work. So I'm just going to take 0, add 30. This one's 30 degrees. I'm going to add 30 to that one. This one's going to be 60 degrees, which means my next one should be 90 degrees, which it is. 90 plus 30 is going to be 120. Then we're going to have 150. Then we should have 180, which we do. Then it's going to be 210, 240, 270, good. 300, 330, and we should go back to 360. Cool. These inside ones are just 15 between. These are smack dab in between these, so I just think add 15. So that one is 45 degrees. This one's going to be 135 degrees. Add 15, this is going to be 225. Add 15, this is 315. I think that method's a lot easier than trying to memorize them all. Some people are good at just memorizing numbers. I like having a nice pattern. So if I'm on a test and I'm under pressure and I forget one of them, I'm just worried about 30, 30, 30, 30, 30, add 15, add 15, add 15. All right, that's the beginnings of our unit circle. That's the smallest thing you need to know for that one. All right, but these are key things that we need to know for the future. All right. We good on that? Any questions? All right, coterminal sides. Coterminal sides are basically 2 angles that are different, but without arrows look the exact same, which means they have the same initial and terminal sides, but one just spins more than the other one. Kind of like, well, we'll just go through. These are the same examples that we had in the beginning. So 120, it has the same terminal side as negative 240, but they are different angles. They are different angles. So we have 120 and we have negative 240. Basically, what you need to think about when I say coterminal angles, the number one thing you should think of is 360 degrees. The only difference between any angle and its coterminal angle is either subtracting 360 over and over and over, or adding 360 over and over and over. And watch. Who wants to venture a guess at what 120 minus 360 is? negative 240. And negative 240 plus 360 gets you back right here. Who wants to come up with a coterminal angle to both those angles? And you can't use 480. Anyone want to make a guess? Yeah, Brody.
What, negative 600?
Negative 600, does it work? What'd you do?
I just subtracted 360 from negative 240.
That will be a coterminal angle. That would absolutely be a coterminal angle. I'm going to use the example from the front, just so all the classes have the same examples, but that works perfectly. You just subtracted 360. All coterminal angles are that angle, either add 360 to it or subtract 360 to it. Because all you're doing is, I'm facing this direction. If I spin this way, still facing this direction, I'm just a little more dizzy. And the more I do it, the more dizzy I am, but I'm a different angle. It just spun that many times. So another coterminal angle, I'm going to go ahead and I'm going to use 480. And it's 480 because if I take 120 and add 360, remember 360 is one turn, then I'm going to know I'm okay. I did one. So that's basically one full thing. Add 120 to it, and we're coterminal. So big thing about coterminal, 360 degrees. When I say coterminal, you should think 360 degrees. I'm going to be still facing that exact same place because I'm just spinning in a circle over and over and over. I was hitting in the same point. All right, that leads us to an awesome formula. Don't let the formula confuse you, okay? All the formula says if you have angles, and we use the Greek alphabet for this, we have alpha and beta. Angles alpha and beta in standard position are coterminal if and only if there's an integer k such that, just write it down with me and I'll explain it to you. The measure of angle alpha equals the measure of angle beta plus k times 360. So all this is saying is, so it says that k needs to be an integer. So k can be 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. All this is saying, to be coterminal, you need to add some version of 360. 2 360, so that's 360 plus 360. Subtract 360, negative 360, negative 360. So that could be like a negative 2. That's just saying I'm going around the negative direction twice. They're saying exactly what I just said. It's either adding 360 over and over and over or subtracting 360 over and over and over. And that's what this is. How many revolutions are you doing to get back to the original one? All right, like this one was 120 plus 360 got me to 480. Does that make sense? Are we still okay? I'm not going to ask you to recite this ever. This is just what I'm saying in more mathematical terms. Okay? Let's go ahead and practice it. So this one says find 2 positive and 2 negative angles that are coterminal with negative 50. Can someone tell me one positive angle that's coterminal with negative 50? Yeah.
310.
310. What did you do?
I just added 360.
You added 360. How would I get to the next one? If I had to get to one more positive?
360.
Add 360 again. What if I asked for 3? Then what would you do?
Add another 360.
Add another 360. If I asked for 4, add another 360. That is 100% fine to do. I'm going to do it slightly different, but we're doing it the exact same way. I am totally fine with you just going to your calculator and adding 360, adding 360, adding 360. I'm just going to use that formula that I showed you before, but I don't care what you do on your homework. All right, so our first one, I'm just going to take I didn't set it up any weird. No, I didn't. So the first positive one, all I'm saying is negative 50 degrees plus 1 times 360. So that K just stands for how many you're going to use. Well, that's just going to equal 310. Honestly, if I was doing this and I had to list another one, I would just add 360 in my calculator. Using the formula, it would look something like this. Negative 50 plus 2 times 360. Does that make sense? It's going to equal 670. But I did what you told me. I'm basically just adding 360 over and over. To go in the negative direction, we're just going to do something like negative 50. If I was you, I'd go on my calculator, I'd subtract 360. But the formula, we'd have negative 50 degrees plus a negative 1 rotation. And then to do that again, I have negative 50, rotate it twice in the negative direction, which will give me negative 410, and it'll also give me 770. I don't care if you use this formula. Just get the right answer. Know what I'm talking about. Know that I mean 360. Something that's happening with 360. All right, determine whether angles in standard position with the given measures are coterminal. How much do I have to do? Okay, we got time. How can I tell if these two things are coterminal? Gracie? By subtracting 360, right? So if I do 190 minus 360 and it equals that, they're coterminal, right? Are they coterminal? Yeah. Yes, they are. Yes, they are. Super easy way to do it. I'm going to do it on this one. I'm going to show you how to use the formula to solve it on this one. I let you do it first because your way usually makes sense. I'm going to use the formula to solve it. So the formula says that if I have my first angle needs to equal my second angle plus K times 360. That K has to turn out to be an integer for them to be coterminal. In other words, is it a full term or is it just part of a term? So following this, we're going to end up with 360 equals 360 times K. K would equal 1. Because it's an integer, it is coterminal. Once again, you don't have to do this. If you're on the test and you just plug in your calculator and you're just like, yeah, it is because I subtracted 360, you might want to tell me what you did so I can see some kind of work in case you were wrong. But I'm fine with however you do it. Are these two coterminal? I don't care how you solve it, just look to see if those two things are coterminal. I see a lot of head shaking. I assume we're all going to say, yes, they are. No? No, they're not coterminal. How many of us just added 360 or subtracted 360 over and over and over? How many of us actually did the formula? Awesome. Either way works. Either way works. The formula is nice if it's really big. You're just solving for something. Subtracting and adding something is nice when they're really close like that. I'm going to go ahead and I'm just going to go ahead and I'm going to do the formula. So I would do something like 880 equals 150 plus K times 360. Doing some work, I would subtract 150 from both sides. That would be 730 equals 360 times K. You divide those out and you come up with 73 over 36 equals K. That is not an integer. Which means it's not coterminal. I don't care how you do it. Telling you it's 50-50. If I was on a test, which one I would use, it all depended on the numbers. If the numbers are really big, and decimals and stuff, I might just actually throw in the formula. If it's really small, I can just add or subtract really quick. So I myself would use both methods depending on the situation. Blah, 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 blah. We're not going to worry too much about that stuff. Complementary, 90 degrees. Supplementary, 180. Do you need me to go back?
No.
Okay. If I ever move too fast, just tell me to go back. All right. We're not going to use these terms very much. Not going to use these terms very much. We're not going to spend a whole bunch of time talking about specific angles. We're talking about how it relates to eventually sine, cosine. All right. The last thing we're going to talk about is these first two. We already did decimal degree. Decimal degree is just what we've been using this whole time. That's kind of our normal. It's kind of that normal measurement of degrees that we've already talked about, where you have like 36.4 degrees. Degree minute seconds, which is right here. I don't know why I made you guys fill this in. This seems repetitive. Degree minute seconds. This is the more exact way to do degrees. This is what you might use if you're an engineer and you have to get a very specific degree to something. And you'll see how specific it is. Degree, minute, seconds are pretty close to decimal degrees. Radians, it's going to be a whole new ballgame. All right, that's what we'll learn about tomorrow. But degree, minute, seconds, very similar to what we've been using. Degrees. Degrees are basically what we've been using so far. When we're talking about just the degree portion of it, is still that 360 degrees, I guess, in one rotation. Minutes. How many minutes are there in an hour? Yeah.
60.
Tough, right? There's 60 minutes in an hour. Guess what? That's round. What we're talking about is round as well. There are still 60 minutes in a degree. The easier way to put that is a minute is 1/60th of a degree. 60 minutes in an hour. There's 60 minutes in a full rotation here, or in a degree. All right, seconds. There are 60 seconds in a minute. 60 times 60 equals 3,600. So a second is 1/3600th of a degree. So when we start talking about seconds, we're talking about a very small decimal point. We get to put a big number next to it. So we're not writing 0.00035 degrees. That's the whole point of degree, minute, seconds, so I can write things in these nice whole chunks that mean this super long decimal if you plug in your calculator. We won't spend a whole bunch of time on degree, minute, seconds. This is your big guy and this guy. Those are your two primary ones. We'll spend a very small time about degree, minute, seconds. That doesn't mean you don't need to know about it. In fact, I will expect you to know how to convert between the two, from degrees to degree, minute, seconds, and from degree, minute, seconds to degrees. We're going to do it. Not mathematically challenging, it's just whether you remember or not. Practice. Converting from degree, minute, seconds to decimal degree. What example did I use? Our example is going to be 32 degrees. It's going to be 5 minutes, so it's 5 with a tick mark, and 28 seconds. Tell you right now, that's a super small decimal, so we're going to be rounding by the time we get 2 degrees. This is the easier way to go of the two. All you have to do is carry down your whole number. So let's carry that 32 degrees down. Then we're going to divide minutes by 60, and we're going to divide our seconds by 360. So we're going to take this 5 and divide it by 60, and we're going to take that 28 and divide by 3,600. Really, you just have to remember the 60 and the 3,600, and all you're going to do is add those together. So it's just going to be 32 plus 5 over 60 plus 28 divided by 3,600. And unless my math is terrible, which sometimes when I plug in my calculators really quick, I got something about 32 0.0911 degrees, but it's just the one continues or something. Does that sound right for people that plugged in? Nice number? Not such a nice number. This you can plug in exactly. This one we had to approximate. So this is a much more exact form. Like I said, it's for like highly specialized degree people, which we will not be in here. Most of our degrees are nice whole numbers that are easy to work with. All right, now what if I have to go the opposite direction? If I have to go the opposite direction, here's going to be my example. We are going to do 56.735 degrees. First thing we're going to do is we're going to carry our 56 down. I'm going to carry it way down here. I shouldn't put degrees yet. I'm just going to put 56. Yeah, we can put degrees. Our next thing is multiply the decimal by 60. So take that decimal, multiply by 60. Let's just do that first, then we'll talk about what's happening next. So I'm just taking this decimal, and I'm going to multiply it by 60. So we're going to do 60 times 0.735. I got out 44.1. Is that what other people got? You are going to take that 44, just the 44 part, and you're going to put it right here. So it's 44 minutes. Now we're going to take that 0.1 and multiply that by 60. Can someone tell me, even though we're dealing with seconds, why did I not multiply it by 3600? Why did I not multiply it by 3600 if I had 3600 here? Liv? I already multiplied it by 60 once. I really am multiplying by 3600. It was just I multiplied by 60, multiplying by 60 again. So I did not lose that 3600. Some people, when we go this way, what happened to the 3600? It's in there. It's 60 times 60. So we're going to take that 0.1. What color did I use yet? I guess yellow. Yellow doesn't really show up. I don't like it. Blue. Blue. So we're going to take that 1, and we're going to go 60 times 0.1, which just happens to equal 6. So we're going to have 6 seconds. If you need to round this, I always round to the nearest whole integer. Not a big deal. If I really care, I'll tell you. I'll say round to the 10th or something like that. But generally, when you're talking about seconds, it's such a small decimal. Way over there, you round to the nearest whole. Otherwise, we're splitting hairs too much. So usually just round to the nearest whole integer. All right? Questions? Comments? Concerns? Worries? Angers? Fears? Happinesses? Joys? Sadnesses? Tirednesses? Excitednesses? We're good? If you look right after the lesson, it says homework. That is your homework. It's not a terribly long assignment. I hope not. If it is, just come see me. We'll talk about it. Answer key is online already. It is on Google Classroom. Let's just get out of here. Give you a solid 1 minute.